All right, gentlemen, let's get to business. Where the STP is Mr. All-You? Hello, Mr. All-You. Did your lunch go well?
Oh yeah, nearly bought out the whole restaurant, you know, with all the money I have for my stable manufacturing business. Volume business must have raised to the moon by now.
Just shut up, Mr. All-You. Just because your profits increase every time mine decrease doesn't mean you get to rub it in my face.
Now, gentlemen, let's not get unstable here.
Chemist is right. We shouldn't bounce our angry molecules in constant random straight line motion. It's so cold.
Oh yeah, Mr. Temperature, where's your mass heavier towards? Me or this pressurized goof?
Listen, we're not here to exert force on one another. We are here for business only. So shut your particles up and keep far away from each other as usual. So, why did your brilliant scientist masters tell you all to come here?
I don't know. Something about representing. That's it. I'm turning up the temperature.
Correct. You lobbyists were assigned here to come here and discuss a possible combination of all your gas law businesses. Why? Because frankly, your rivalry has just become a little too unstable recently. Because these businesses need to become as stable as the noble gases. We gotta form the combined gas laws. All three together, is the only possible way. Okay, make it look a little more interesting, we should start by introducing the individual gas laws. Mr. Aperture, why don't we start with you?
Oh, alright. So, my name is Tim Aperture, and I represent Boyle's Law. First of all, temperature is constant, so... Oh. Hold on a sec. Let me just copy the thing down. Okay, so here's where the math comes in. Say if I had 75.0 cubic centimeters and it has a pressure of 95.3 kilopascal, or kPa for short, but the question is here, what is my new volume at a pressure of 101.3 kPa? So the equation for this is V2 equals 75.0 cubic centimeters times 95.3 kPa over 101.3 kPa. Whenever pressure increases, volume decreases. Or when volume increases, pressure decreases. This fraction here, because the pressure went up, the volume has to go down.
I wish mine went up.
Yeah, right.
Which brings me to my final answer of V2 equals 69.1 cubic centimeters.
Fantastic, Mr. Aperture. Alright, who's next?
That's in the Charles Law, the volume temperature relationship pressure is constant.
Mr. Rescher, your voice molecules aren't filling up this room like they should be.
Okay, so my name is Pete Rescher, and I'm here representing the Charles Law. The Charles Law is a volume temperature relationship where pressure is constant. Alright, so right here I have 273 Kelvin written, which is part of the standard temperature and pressure. Because when we measure temperature in the gas laws, we do not use Celsius. Instead, we add whatever Celsius is given to the standard temperature, 273 Kelvin. So if I have 25 centimeters cubed of nitrogen gas at 296 K, what would the volume be at STP? The equation for volume 2 would be V2 equals 25 centimeters cubed times 273 Kelvin over 296 Kelvin to give our final result as volume 2 as 23.06 centimeters cubed.
Alright, good job, Mr. Rescher. You can sit down. And lastly, Mr. Vlad, all you.
Alright, my turn. Okay, this is a gay-lussac law. In this law, the volume is constant, while the temperature, it's a temperature and pressure relationship. In this relationship, when the temperature goes down, so does the pressure. So in our problem here, temperature 1 is at 298 Kelvin. We're trying to find the temperature 2, with the pressure at 50 kPa, changing to 20 kPa. So as we come down here, temperature 2 will equal 298 Kelvin times 20 kPa over 50 kPa. So in the end result, temperature 2 will equal 119.2 Kelvin.
Alright, thank you, Mr. Allium. That's it! I found it! Yes, this works! It works! So I held all this. Volume, temperature, and pressure. Right? And they're not constant. V2 is equal to 320 centimeters cubed times 333 Kelvin divided by 295 Kelvin times 90 kPa divided by 130 kPa. Thus, V2 is equal to 250.1 centimeters cubed.
Oh my god, I just got promoted! Oh, so much pressure. So much pressure.
Oh, fever, chills, fever, chills, fever, chills.
What happened to my volume? I'm so hungry.
Wait a minute. Wait. When are we getting paid?
Paid?